Hey everyone, welcome to Homework 1.25. Today we looked at some more inequalities, systems of inequalities, and finding possible solutions by graphing. So a couple of quick reminders because I saw some of you had questions about this today. If it is the area that works, then it is the shaded area, okay? So if you test a point and we test on this side and that line works, then that point works rather, then we are shading that side. This shading represents where our solutions are. All right, so that's just a reminder or review to make sure that's really crystal clear. So this first part says to write a system of equations for Jada, who has P pennies and N nickels that adds up to more than 40 cents. More than tells me that I'm going to be greater than 40. She has fewer than 20 coins, so less than 20 coins. And we need to write inequalities for both of these, right? So pennies are worth 1 cent each, and we're looking at 40 cents. So this would be P plus 5 cents per nickel is greater than 40, and then P plus N, the number of pennies and nickels, is going to be less than 20. Now, you can also write this as 0.01 P plus 0.05 N is greater than 0.4, right? Because if you want to put it in terms of cents, you can write it in terms of cents in the dollar, right? Or you can write it as just like in terms of total cents, 100 cents, right? 40 cents. You can leave it as such. These are equivalent because if I were to multiply this whole thing by 100, it would be 1p plus 5n is greater than 40. Okay? It says, is it possible that Jada has each of the following combination of coins? If so, explain how you know. If not, state which constraint, money or number of coins, it does not meet. So 15 pennies and 5 nickels. Looking at that immediately, 5 plus 15 equals 20. 20 is not less than 20, right? And so this would work for the first equation, for the equation about how much money it is, but not the number of coins. So this is no, not the number of coins. The second possible combination is 16 pennies and 2 nickels. Well, 16 plus 2 is less than 20, so it works for that number of coins. So let's see if it works for the amount of money. So 16 pennies would be 16 cents, 16 times 1, plus 10 cents is greater than 40. That is not true. So that's 26, which is not greater than 40. So this we would say no, because of the amount of money constraint. All right. The next one says 10 pennies and 8 nickels. So this would be 10 plus 8 is less than 20, so it works for that one. And then 10 cents plus 5 times 8 is 40, is in fact greater than 40. You would get 50. 50 is greater than 40, so this one is yes, it works for both. So remember, for a system of equations, in order for the point to be a solution for both, it has to work for both equations or be in the double shaded area. So number 2 says a triathlon athlete swims at an average rate 2.4 miles per hour and bikes at an average rate of 16.1 miles per hour. So notice that we have swimming as our x value and biking as our y value. At the end of one training session, she has swum and biked more than 20 miles total. The inequality 2.4s plus 16.1b is greater than 20. And this graph represents the relationship between hours of swimming and hours of biking and the total distance the athlete could have traveled in miles. Mai said, I don't think this graph is right. For example, the point 10.3, so that's over here, right, 10.3, is in the shaded region, but it's not realistic for an athlete to swim for 10 hours and bike for 3 hours in a training session. I would agree. Swimming for 10 hours is probably not possible. It says, I think triathlon athletes generally train no more than 2 hours a day. Write an inequality to represent Mai's last statement. So if they are swimming and biking for a total of less than 2 hours, we would say S plus B has to be less than or equal to 2. So swimming, the amount of time swimming and the amount of time biking has to be total to be less than or equal to 2 hours. graph the solution. So I have this other graph here. I wouldn't use that one because it's too big. Let's look at this graph over here because the increments are better. So if we put this into slope-intercept form, our y value is biking b. So we're going to solve for b and say b is less than or equal to negative s plus 2. Okay, if it's helpful for you, you can change s and b out for x and y. Sometimes that's helpful for me because to remember which is on my x-axis and which is on my y-axis. So our y-intercept is 2, so this will start here, and it is less than or equal to, so we're going to have a solid line, and it's a negative slope, and it's negative 1 over 1. So we're going to go down 1 over 1, down 1 over 1, and then I'm going to go ahead and draw my line. And it's less than or equal to, so if I put 0, 0 in here, 0 plus 0 is less than or equal to 2. That does in fact work, so the side that I'm going to shade is going to be over here. Right, and now I'm looking for my overlapping points. So notice that overlapping spot is actually pretty tiny, right? So we've done that graph there, right up here, say C graph. And it says determine the possible combination. So a possible combination would be in here somewhere. This looks about to be, this is 1 here, so this looks to be about 0.5, and then up maybe about 1.5 would work. So I'm going to say 0.5 comma 1.5, which means 0.5 hours of swimming and 1.5 hours of biking, which seems a little bit more realistic for a triathlon athlete. Probably not realistic for me, but a triathlon athlete could do that. All right? Okay. Number 3. Elena is considering buying bracelets and necklaces as gifts for friends. Bracelets cost $3, necklaces cost $5. She can spend no more than $30 on the gifts. Elena needs at least 7 gift items. So we have one inequality rather here, which gives us the cost, right? She can't spend more than $30. And we have bracelets on our x-axis and N necklaces on our y-axis. It says let B represent the number of bracelets and the number of necklaces. Write an inequality that represents the number of gifts. So we have at least 7. So this is going to be greater or equal to 7. And we have bracelets plus necklaces has to be greater than or equal to 7. So now we're going to go ahead and add this to the graph. So let's go ahead and remember necklaces are y value. So we want to solve for n. So n is greater than or equal to negative b plus 7. And so this means we have a y-intercept of 7, and our slope is negative 1, so down 1 over 1, down 1 over 1, all the way down. And it says at least, so that is including 7. It could be 7, or it could be more than that. And then it's greater than or equal to, so if I were to test 0, 0 here, we were to say 0 is greater than or equal to 0 plus 7. That is not true. 0 is not greater than 7. So in this second line, this does not work. Therefore, we're going to shade the other side, right? And you could test another point on the other side over there and see if that works. If I were to test, for example, 10, 2, right? 10 plus 2 is greater than 7. It's 9, so, or 12 rather, so that works. All right, so this is the side. So our double-sided is going to be this triangle here. So we can say, C graph here. And then it says use the graphs to find at least 2 possible combinations of bracelets and necklaces. So one I see here is 8, 1. That would work. And we could also have maybe 7, 1 as well. It's in the shaded area right here, right? Or here, this point here. So 6, 2 would also be fine. It says explain how the graphs show that the combination of 2 bracelets and 5 necklaces meet one constraint in the situation but not in the other. So 2 plus 5 is greater than or equal to 7. Oh, I wrote 6, but I said 7. There we go. Greater than or equal to 7. So it works for the number of presents. But in terms of cost, if we were to have 2 bracelets, that would be 3 times 2 plus 5 times 5 is going to be 6 plus 25, which is 31, which is not less than or equal to 30, which is our budget, right? We can also look for that point, so 2, let's see here, right? 2 comma 5, yeah. 2 comma 5 is right here on our graph, but that's outside of the shaded area of the other graph, right? It's only in one of the shaded graph areas. So that's 2 comma 5, all right? So not quite something that works for both of them. And I don't know if you can actually, because I drew over that. So it works in that green shaded area, but 2 comma 5 is right here. So it's outside of this blue shaded area. It's kind of hard to see when I had the color over it, but that's why it only works for one of the equations, as you can see on the graph and by substituting. All right, number 4, a gardener is buying some topsoil and compost to fill his garden. His budget is $70. Topsoil costs $1.89 per cubic foot, and compost costs $4.59 per cubic foot. Select all statements or representations that correctly describe the gardener's constraints in this situation. Let T represent the cubic feet of topsoil and C the cubic feet of compost. So it says the combination of 7.5 cubic feet of topsoil and 12 cubic feet of compost is within the gardener's budget. So let's write our inequality. Budget is 70, so less than or equal to 70. And we have 189 T times T plus 459 C compost. So if I plug in 189 times 7.5 plus 459 times 12, you want to see is that less than or equal to 70. So I'm going to let you compute and decide if that one works or not. So you have to decide yes or no. Letter B, if the line represents the equation 1.89 plus 4.59c equals 70, this graph represents the solutions to the gardener's budget constraint. So is this graph that has a dotted line representative of this inequality? Notice we have a less than or equal to sign. What do you think? Decide yes or no. Letter C says that we have this equation with a greater than or equal to sign. Remember, the budget is 70, so we know that that is not one of our solutions. Letter D says the combination of 5 cubic feet of topsoil and 20 feet of compost. So again, you're going to substitute in here and see if this works, right? If we were to do that, is that a valid cost? And then letter E does match our equation with less than or equal to, so E looks good. And F, if the line represents the equation, this graph represents it. So notice this has a solid line here, so you want to see, is that an accurate graph? Yes or no, and you can decide. All right? So tell me which ones are accurate, which ones are not. You have to do the computations to decide, though. The last one, number 5, Priya writes this equation. Write an equation that has exactly one solution with Priya's equation. So as long as there's a different slope, then we can have a different solution. So if we said y equals 2x plus 1, that's going to have one solution. No solutions to common. So that would be a parallel line, which means we have the same slope, negative 1/2 x, but a different y-intercept, say plus 1, minus 6, whatever you want it to be. Infinitely many solutions would be the exact same equation, so y equals negative 1/2 x minus 7. You could also say, right, if we were to multiply that whole thing by 2, 2y equals negative x minus 14. Okay, that would also be an equivalent equation, which would mean it would have the exact same line and therefore infinite solutions. All right, your homework code, if you want to stop here, will be highlighter. Highlighter is your homework code today, but I'm going to go ahead and go back up. Maybe, come on. It's taking a second to load, which is really weird. Oh, there it goes. Okay. Go back up to your classwork really quick so you can take a look at this. So, you can hear my papers rustling. I'm only going to go over problem card number 2, because we mostly did 1 in class today. But we have x is greater than or equal to 3y, x plus y is less than or equal to 20, and y is greater than or equal to 2. If you graph these, let's start with this one. This is the easiest one to graph, right? We're starting with y is greater than or equal to 2, horizontal line. Everything above that line is going to be shaded. There we go. That's done. All right, now we're going to look at the next one. And this one, let's go ahead and put it into slope-intercept form. That's an arrow, not a negative sign. So y is less than or equal to negative x plus 20. Start at 20, we're going down 1 over 1, right? So nice even blocks. These are going by 2, so down 2 over 2 is the same as 1 over 1. That's fine. And it is less than or equal to, so we are going to go ahead and make dotted line there. Oh, I'm sorry. Less than or equal to, we're going to make a solid line there. Woo, solid line. I got really excited about the dotted line. And then I need to figure out, is it less than or equal to? So what side am I shading? Well, if I plug in 0, right, if I plug in this point, 0 plus 0 is less than or equal to 20. So now I'm shading on this side of the triangle all the way down. Okay. And then our last equation, x is greater than or equal to 3y. I want to put this in slope-intercept form. So x is greater than or equal to 3y is the same as, divide both sides by 3. We get y is less than or equal to negative, oh, not negative, 1/3. There's no negative there. 1/3 x. Okay? Now remember, x over 3 is the same as 1/3 times x. All right, so that's where I got that slope of 1/3. So here we don't have a y-intercept. Our y-intercept is 0, so we're starting at the bottom, and we're going up 1 over 3. So up 1 over 3. Now, this graph is going in 2's, so I would go ahead and multiply this whole thing by 2 over 2, which is going to be 2 over 6. So up 2 over 6, which will make it easier. So up 2 over 6. Up 2 over 6. Up 2 over 6. And then now we have our graph here, okay? We are then going to say, well, what side of this are we going to shade? And we're going to shade our, let's see, at least 3 times of adult, so this is actually also solid line. And I wrote that greater than or equal to here. Okay, like this. And so here I want to plug in a value here. Let's try 10, 2. If I were to plug in 10, 2, would that work for this or not? So if we have 10, oh, for some reason it's not right. There we go. 10 is greater than or equal to 3 times 2. 10 is in fact greater than or equal to 6. So that tells me for this other line, let's change our highlighter color. I'm going to graph below the line. And so now the area that is shaded in for all 3 is in this triangle right here. So that'll help you then to answer the questions, right, and graph this. We can say which combinations of children and adults would work. All right? If you have any questions, please reach out. Again, the code word for today is highlighter. Happy homeworking and see you tomorrow.